Hello students. So in continuation with our earlier lecture, we will study indirect methods of soil moisture estimation. So in direct method we studied how to estimate soil moisture. First method is thermogravimetric method and second method is volumetric method. We studied the procedure and calculations of both the methods. Now indirect methods, in this method we determine soil moisture not directly, but we will measure some other parameters, and based on that we can understand the percent moisture in the soil. So in indirect method, first method is a tensiometer. So this is a typical diagram of tensiometer. Tensiometer, it has vacuum gauge. It is also called as pressure gauge. Then it has two tubes and inner tube and outer tube. So inner tube is to hold the moisture inside, and outer tube is to protect the moisture or water present inside. We should not say moisture but water present inside. Then at the end we have got porous cup or porous tip. So the length of this tip is around 7.5 to 22.5 centimeter. Okay, and we have to insert this porous cup near the root zone of the crop. So make a hole with the screw auger and insert this where the crop root zone is there, and you add water inside the inner tube. And when the soil is dry, the water will enter from this inner tube and passes through the porous cup. Porous cup is usually made up of ceramics. It is porous. So water will start entering in the soil through this ceramic porous cup when the soil is drier. And when the soil is dry, that means there is a more tension present in the soil. The tension is more, the pressure is more, that we studied in theory. When the soil is dry, tension is more. When the soil is wet, tension is less. So as water enters through this porous cup, it will create vacuum here. And this water goes down and vacuum will be created, and this vacuum is measured on vacuum gauge, or we can say pressure gauge. So this is the simple operation of tensiometer. So we can measure the soil moisture tension by using tensiometer. So on this pressure gauge, the tension is calibrated, and it is recorded, it is calibrated from 0 to 1 bar. And tensiometer can only work up to 0.85 bars. Beyond that limit, it cannot work. And it is suitable for sandy soils, but it is not suitable for clay soil. The reason is that in sandy soil the tension is less, and in clay soil the soil moisture tension is more. That is why it will not work in clay soil, but it can work in sandy soil. So this is about tensiometer. So this is the first instrument that we can use to measure the soil moisture tension. Second instrument is gypsum block. So this is the diagram of the previous batch students, and you can draw similar diagram in your manual. Gypsum block, which are the parts, Wheatstone bridge or Bicos meter, Wheatstone bridge or Bicos meter, adjusting knob, gypsum block. This side, at right hand side, we have got gypsum block, very square. Electrodes, gypsum block is connected with the electrodes, and electrodes are connected with cord, and that cord is connected to the Wheatstone bridge. So what we measure with the help of Wheatstone bridge or Bicos meter? So with the help of Wheatstone bridge, we can measure the resistance to the flow of electricity. That is capital R, resistance to the flow of electricity. Because it is not possible to measure or difficult to measure the electrical conductivity in the soil when the water is there, and therefore we use resistance, not conductivity. Now what is the procedure? We have to place this gypsum block along with electrodes in the soil near the root zone of the crop. Place near the root zone of the crop. And when the soil is wet, WET means there is water in the soil. When the soil is wet, electrical conductivity will pass from the gypsum block through the electrodes. Conductivity will pass from the gypsum block through the electrodes, and when the conductivity is more, the resistance is less. When the conductivity is more, the resistance is less. So we can say that here we can record resistance when the soil has more moisture, less resistance. And when the soil is dry, conductivity is less. Conductivity is less, and when the conductivity is less, resistance is more. When the conductivity is less, resistance is more, and that we can measure on Wheatstone bridge or Bicos meter. So this is the simple principle of working of gypsum block. Okay. So resistance is measured in ohms. We can measure the resistance in ohms, and when the soil has more moisture, so we can say field capacity. Field capacity means where the soil has more moisture. So at field capacity, the resistance recorded is 400 to 600 ohms. 400 to 600 ohms. And at permanent wilting point, where there is less moisture in the soil, the resistance recorded is 36,000 to 70,000. So we can say 40,000 to 70,000 ohms. So you can say 100 times more than the field capacity. So at permanent wilting point, we will measure high resistance, and we can say that when resistance is high, soil is getting drier. So this is how we can measure the percent moisture based on by using gypsum block. Then pressure plate apparatus. Pressure plate apparatus. In this method also we can measure the soil moisture. This method is laboratory method. This is a laboratory method. Here which are the parts? First is a airtight metallic chamber. Airtight metallic chamber. So it is a chamber which is airtight, like our pressure cooker, for example. Airtight metallic chamber which is connected with the pressure application source is also called as compressor for giving more pressure. Compressor means like we use air pump for filling air in tires. In a similar way, we have got compressor here to apply pressure and pressure is we apply pressure in bars or in atmosphere. Atmosphere is one unit that I shared in during theory, and bar is another unit which is similar to atmosphere. So 1 bar is equal to 0.98 atmosphere. Please remember, this is very important from examination point of view. 1 bar is equal to 0.98 atmosphere. So it is more or less similar. And when you apply pressure, and inside the airtight metallic chamber, here there is a soil sample. You can place soil sample, and you can place the soil sample on the ceramic plate. Here again there is a ceramic plate which is made up of ceramics. So you can place soil sample on ceramic plate, and this ceramic plate is connected to the manometer, or it is also called as outlet or manometer, from where the water should go. So procedure is, bring the soil sample from the field, keep on the ceramic plate, apply pressure through the compressor, through the pressure application source, 1 bar, 2 bar, 5 bar, 10 bar, whatever you want, because this is usually used for experiment. Apply whatever pressure you want, and when you apply more and more pressure, more and more water will be drained out from the outlet, from the manometer, and the sample, the remaining soil sample which is there on ceramic plate, you can remove it out from the chamber, and you can dry it in the oven, and you can determine the percent moisture. Then you will get the figure of percent moisture for that particular applied bar, particular applied pressure. So for example, you applied 4 bar, then you will get percent moisture for that particular 4 bar. Okay, so this is how you can determine the percent moisture by using pressure plate apparatus. Okay, so these are the 3 important methods. There is one more method, neutron probe, but that is not so important. So these are 3 important methods for determining the soil moisture. Okay,